Welcome to the first video in the IoT in Practice workshop. This is a mini-series introducing you to the world of the Internet of Things, during which we will be completing a project for a full IoT system. But what exactly is the Internet of Things? Let me give you an example. At home, you have a temperature sensor that sends data to a server. The server analyzes the data and determines that the temperature is too low, so it sends a command to the thermostat to increase the temperature. In turn, you see in your phone app that the temperature is 17 degrees Celsius and the thermostat has been set to 25 degrees Celsius. In summary, the Internet of Things is a network of interconnected devices that collects data and exchanges it with each other over the Internet. Examples of IoT applications include smart homes, controlling lighting, heating, and household appliances; health monitoring, tracking steps, heart rate, and blood pressure; Industry 4.0, machines reporting production status and failure predictions; agriculture, humidity sensors and irrigation assistant devices; smart cities, street lighting controlled by human presence and parking systems. An IoT system consists of four basic components: the end device, the network, the server, and the user interface. End devices are, for example, a microcontroller with a sensor. Their tasks are to collect data from the environment, perform preliminary processing, and transmit it further. The network enables data transmission between devices. Using the example of two people, you could compare it to a conversation. The conversation can place in various languages, which in turn can be likened to communication protocols such as MQTT, HTTP, or Bluetooth Low Energy. The server is the place where data is collected, further processed, and if necessary, transmitted onwards. The user interface is, for example, a mobile application where you can remotely control the device, or a display presenting the data. In the following workshops, we will be implementing a weather station project step by step. It will consist of a microcontroller with sensors and an in-paper display, a server with a database, and the communication between the server and the microcontroller will occur via the MQTT protocol. If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Altium Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Altium Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it, you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections. We will install the system on a Raspberry, add an MQTT broker and a server with a database to it, configure the Xiao microcontroller, read data from the sensors and transmit it to the server, finally add the display to the project. During the workshop, we will be using the following components: Raspberry Pi Pico 2W, Xiao ESP32C6, WIACT 2.9 e-paper display, and sensors for temperature, humidity and pressure, sound intensity, air quality, and light intensity.